to be on the call today. Thanks for making our time to be here. So this is another way of ID analytics giving back to a vibrant community. We have past alumni, data enthusiasts, and experts in the community. So in order to give back, in order to ensure we are up to date with our data analytics skills, we do this every last Saturday of the month for our community. So I'll be moving on to what we do at ID Analytics. ID Analytics is a training and consulting firm where we empower individuals and organizations to harness the transformative power of data by ensuring they thrive in today's analytics-driven landscape. So in a nutshell, what we do at ID Analytics is train individuals, train organizations, provide tailored solutions when it comes to data for any organization. So if you're looking, if there's anything that has to do with data that you need clarity on, ID Analytics is the place to be. And then I'll be introducing our speaker, Olabisi Olaleye. She is a business intelligence analyst. Olabisi Olaleye is a Microsoft certified data analyst and trainer with experience in designing scalable data models and building visual analytics that drive business performance. Beyond her core role, she has trained and mentored over 100 beginners through her work with quantum analytics and Swift profile. Olabisi believes transformation begins with choosing authenticity over perfection, and that's what every data analyst should strive to do. She encourages this mindset in everyone seeking growth. I love the last part. I'll be handing over the microphone now to Olabisi Olaleye. Kindly join me to welcome her as she walks us through data modeling for the next 1 hour. And kindly ensure you prepared your questions, because after the session, she'll be attending to your questions. And if you need clarity as well. Olabisi, you have the floor now.
Hi, Mercy. Thank you so much for the beautiful introduction. Please kindly confirm that you can hear me.
Very clearly.
All right, thank you so much. Hi, everyone. My name is Olabisi Olaleye, and I am a business intelligence analyst and a Microsoft certified trainer. And I feel like Mercy has already done justice to my introduction. So we'll just get right into it. So please give me some seconds to share my screen. Please let me know when you can see my screen. You can just make a reaction.
Yeah, it's up
it's
now.
Up. Okay, all right. All right, thank you so much, Mercy. All right, hi everyone. Hi once again. I'm excited to be here really, and I hope that we are too, because I feel like we need the excitement to go both ways so that this session can be a success. So we're going to be covering data modeling in Power BI in today's session, and these are the basic aspects that we're going to be covering: what data modeling is and why it matters, tables and columns in terms of creating relationships, the relationships themselves, and schema. And I'm gonna add to add a little bonus of best practices and common mistakes that we can look out for when we are modeling our data in Power BI. And there's also the aspect of questions. So moving on, I would also like to hear from us. Before now, have we heard of data modeling before? If yes, what do we know that it is? If no, what do we think that it is? I'm just going to allow maybe 1 or 2 persons to respond so that we don't take much of our time on that. So if you are willing to respond, you can just make a reaction and you can unmute and speak. Thank you. Anyone wants to respond? Okay, so in the absence of no response, we just get right into it. That's the reason why we're here, to learn really. So yes, what is data modeling? I'm going to start with this library analogy to give us like a real world example of what data modeling does in terms of our analysis. So now imagine that you walk into a library with thousands of books, or basically let's even say a room with thousands of books, and you just need to pick out like 5 books, 5 data related books, but you have thousands of books piled on the floor. How do you even start looking for what you need? That's going to be like a nightmare, yeah? So now imagine that these same books are now sorted by genres, they're labeled on shelves, and also related sections are now, they're now linked. You can see where data related books are labeled and all. This makes it easier for you to find what you need, right? That is exactly what data modeling does. It does something similar for you. So your data, you can see your data as a book, and data modeling is the organizing and connecting everything together to make sense. Sorry, please give me some seconds. I want to, yes, so that I can use, exactly. So it makes sense. So in simple English, data modeling is you defining and creating relationships between tables. It's basically you determining how your tables are related to each other, and you defining that relationship. And when relationships are created between tables, what this does for you is that this creates a linkage between the data that are stored in this table. And this linkage is what Power BI needs really to help you carry out proper analysis in terms of cross-table analysis. So let's say, for example, that I want to create a calculation. I need insight on total sales that was made in a particular region, and I have sales amount in a sales table, and I have region in another table. How do I link these two things together in my calculation and get the correct insight? That's basically what data modeling helps you do. It creates relationship between tables, and this linkage helps Power BI combine the data between these two tables properly for your analysis. Please, do we get this aspect? You can do like a thumbs up if you get what data modeling is, so that we can move to the next thing. Please, do we get what data modeling is? Okay, thank you. So now moving to why data modeling matters. First on my list here is fast report performance. So if you have a good data modeling, if your data is properly modeled, it helps your report to perform faster, improves your report performance, basically. Accurate, trustworthy visuals. I just mentioned in terms of insights, you can trust the insights that you get, that you have on your visuals. Simple readable DAX. You don't have to create complex DAX, because you can pick things from different tables, and you can be sure that you're getting like the correct output. And easy to update. It is easy to update and expand your table as you would want to, and it also serves as a single source of truth. So now moving on to tables and columns. So how do tables and columns work in terms of relationship? So in data modeling, basically when you are creating relationships between tables, you need 2 types of tables here. The first one is a fact table. The second one is dimension table. So now you can be asking in your mind, how do I know what a fact table is? How do I know what a dimension table is? So let's say that you have a data set, for example, a sales data, and you have, let's say, 3 tables. The first table is titled sales. The second is titled customer, and the third table is titled product. For you to identify your fact table between these 3 tables, you just have to look out for the one that contains numerical data, basically data that is measurable, and also contains foreign keys. So I will still explain foreign keys to us, but basically foreign key is just you having a column from other two tables. If I have something, if I have a column in customer and product inside of sales, sales is my fact table. So these are like two major things to look out for when you are trying to figure out what your fact table is. And dimension tables basically just describe. So in terms of who, that's your customer, what products that you're selling, when, the time, basically date, at the time that you sold, date, and days, week, and the likes, and where, location or platform that you have sold this particular product, or you have made sales, or that your business have been carried out. So these are the two types of tables that we have: fact tables, dimension tables, and relationship occurs in data modeling between these two tables. Now, moving on to columns. You need two types of columns to be able to create the linkage between these two types of tables. So now I've explained that we have fact tables, we have dimension tables, and these are the two tables that relationship occurs between here. So now what makes this relationship occur? That is your primary key and your foreign key. So now what is your primary key? This is the column that contains unique rows in a table. So for example, the example I made of you having three tables: customer table, sales table, and products table. Now, you have identified that your customer table is a dimension table. Your product table is a dimension table because they're basically describing. The customer table is describing who has bought from you or who you have done business with. The product table is describing what you the business that you do, what you sell, for example. And your sales table has recorded the values that you have made on from your business. So now your primary key you usually find it in the dimension table because they are always unique, they contain unique rows. So now for every customer that you have done business with, when you are recording their data in your customer table, you can only register one customer in that table. You cannot register one customer two times because they are still the same customer. Their name is still their name, their email address. So one customer as one record. So this makes this particular table contains a unique rows of the people that you have done business with. The same for your products. So let's say, for example, that I run a business and I sell 5 types of products. I don't sell 5 products, I sell 5 types of products. So let's say, for example, that I sell let's say I sell books, and maybe also bags and shoes, and what else? Let's say I also sell kitchen utensils, and the 5th one, let's say I sell sportswear as well. These are 5 types of products that I sell. They are not just the 5, they're not just 5, they're not the quantity of products I sell. Yeah, I can sell all these products in as much quantities as I want to, but they are the only 5 types of products that I sell, which means that in my products table, I'm only going to have 5 rows. And each of these rows is going to be uniquely defining every type of products that I sell, which are just 5 in number, basically: books, bags, shoes, kitchen utensils, and sportswear. So now for your foreign key, this is a matching column of the primary key in the fact table. I already briefly touched it here. So for my primary column that I have in my dimension table, if I can find it in the fact table, that is my foreign key inside of the fact table. So now I'll just quickly do like a bit of summarization of these two. Primary key is the column that contains unique rows in the table, and you usually find them in your dimension table. They uniquely describe the records in your dimension table. For example, your customer ID inside of your customer table. Now, foreign key is the matching column of that primary key inside the facts table. So what that does in your facts table is basically now describing who you have done business with. So on the 1st of May 2026, I sold to customer ID 1, and I have that record in my sales or orders table. On the 5th of May, they came back. I would have to still include their ID because this is a different sales from the one that I made on the 1st of May, basically. So this is what your primary key is doing inside your fact table as a foreign key. In your dimension table is basically just describing the customer, but now once it is in your fact table, it is describing who you have done business with at a particular time. So please, if we get this, we can like do a thumbs up before I move on to the next. Are we good? Can I move on to the next? All right, thank you. So now we have what we call relationship types. This is represented as cardinality in Power BI environment. I'm still going to do like a practical walkthrough for us on how we can relate tables in Power BI environment itself. But we have different types: one-to-one relationship, one-to-many relationship, and many-to-many relationship. So now for one-to-one relationship, this is when one record in a table corresponds to exactly one record in another table. So let's say that you bring in your data into Power BI. Another thing that Power BI does is it also detects relationships, but it is always very important for you to review those relationships to be sure that the keys used or the way that it has been related is how you want it to be actually related. So now when you bring in your data into Power BI environment, it also detects. And when you see like the one-to-one, I'll show us what it looks like. We'll still like go through it. What should come to your head is that, oh, there is one record in this table corresponds to exactly one record. There are no duplicates in the other table. So both tables only have one record of a particular way. Like there are no two records of what is here inside the other ones. And an example is you can think of an employee details table and a payroll table. So when you are trying to connect these two types of tables, you would get a one-to-one relationship because the employee ID in the employee details, which is describing the employee, is going to be unique. In the payroll table as well, it's going to appear once because the employee gets paid once, right? So in this type of table, when you try to connect them, you would get a one-to-one relationship. The next one, which is a one-to-many relationship, this is the most common and most recommended type of relationship. Here, one record in a table matches with many records in another table. Take the example of I have an example here which is pointing to sales, but I think because I mentioned one in terms of customer where I said that. So if you make a sales on the 1st of May 2026 and customer ID 1 is the person that you sold to, and they are coming back, like you have that record in your sales here, and they're coming back on the 6th of May or 5th of May to say, want to buy again, you would have their ID recorded again alongside that sales, because even though it is the same customer, it is a different sales for you, different payment, different transaction entirely. So when you are relating your customer ID to your sales, your customer table to your sales table, you would most likely have a one-to-many because one customer can buy from you multiple times. And it is important that you record each sales that you make, because regardless of who is buying, even if it's the repeating customer, it is a different sales for it is a different income for you, for your business. So that's basically what one-to-many relationship is, when one record in a table matches with many records in another table. Many-to-many relationship. This relationship occurs when many records in one table relates to many records in another table. And I feel like you would already get what this is from my previous expansions of one-to-one, one-to-many. But then this relationship actually requires careful implementation because it can introduce ambiguous filter behavior, unexpected results. For many-to-many relationship, it is usually advisable that you create a bridge table, basically, because you don't want to introduce ambiguity into your report. You don't want issues with your report. So if it is important that you relate these two tables that has many on one side and many on the other side, it is advisable that you create a bridge table. So now, example of a many to many in the case of students and courses. So you know that let's use an example of a university where students can enroll to many courses, and courses can also have many students that are enrolled on that course. So in this case, if you are trying to relate these two type of tables, it is always important, or like advisable, let me say, to create like an enrollment table, which is not going to be like your bridge. So your enrollment table can contain the many parts, the courses and the students, the courses and students that have enrolled to those courses, and courses that students have enrolled to, basically. And then on the side, you can just have your student, let's say maybe student details table, the other one course details table, and the student table is just going to like have records of all the students, maybe let's say in the department, and that cannot have duplicates because it's just going to be one record, one student record on one row, basically. And then for the courses that are just going to list out all the courses in that that they're supposed to take that semester, and your enrollment table can now have like the many parts, and you can relate these two tables to your enrollment table. Please do we understand the relationship that I just explained? One-to-one, one-to-many, many-to-many relationship. If we have questions, want to go over any other part of this, please, you can indicate. Okay, moving on. So this is an example of what a one-to-many relationship looks like. So in this case, we have our customer table, our sales table, and our product table. You can see that we have one here and we have asterisk here. Asterisk basically represents many. So on the side where you see asterisk, that is the side where the many is. And whatever side that you see the number one, that's one digit, that is where the one record is. So in this case, we have our customers, which contains unique records of customers. And on the right side here, we have products, which contains unique records of products. And in the middle, we have our sales table, which records every sales that has been made and can contain multiple records of customers, because one customer can or would most likely have come to do business with you, and one product, yes, possible for more than one person or even the same customer to order the same products from you. So now, what is a schema? So in Power BI, basically, you know that I've explained what data modeling is, which is creating. I'm just going to do like a bit of run through on what I've taught so far, so that I can then connect it to schema. So data modeling is defining relationships here, and then we need relationships are created between two types of tables: fact, dimensions, and these relationships are created using two types of columns: primary and foreign key. So now the entire structure of what this looks like is called schema, basically. So a schema defines the structure of the data and how data is connected, related, and modeled. And we have two types of schema. We have the star schema, and we have the snowflake schema. So what does the star schema look like? The star schema is when you have one central fact table connecting to multiple dimension table in a star-like layout. So let me go back to this example. So in this case, you can see that we have one fact table, which is our sales, which is containing numerical data, and customers and products table, both connecting to this fact table. This is an example of what a star schema looks like. So you have just one dimension, one fact table connecting to multiple dimension tables. And a snowflake schema is basically just an extension of what a star schema is. So in this case, in a case where, so the example, the data set I'm going to be using to walk us through the practical aspect is also contains like a breakdown of a particular table. So let me give the example of you have a product table in your data set, but now these products are for the products that you sell has now been further broken down. So now I have products, but then I also have the categories that this product belongs to, and also the subcategory that this category of product belongs to. That's like me having two extra layers to my product. So yeah, these are the products I sell, but oh, I'm telling my customer that these products are also in category. So it's easier for you to say or to find them. So let me use the example of you walking into a store. You have the category for let's say kitchen utensils, you have categories for, let's say, skincare products, you have the categories for maybe body sprays and perfumes. So yes, so this is it. They are all products that the business sells here, but they have been categorized into categories, and the categories have also been further um categorized into subcategories. So this, when you relate, when you have this type of breakdown in your data, it might like make it look like a little bit complex than what a star schema is, which is straightforward, where you know that you're just connecting your dimension tables to only one fact table. So now this is an example of a star schema. I showed us the former example, but yeah, this is a screenshot of something that I did in my in Power BI environment. So here we have 4 tables connected to our fact table. Our orders table in this case is our fact table. We have our sales team table, which is describing the people that we have on our sales team. The locations table, which is describing locations where business is being done. Customer table, which is describing the customers that we do business with. Calendar, this is basically your dates table. And products, describing the products that we sell. So this is what your star schema looks like. One fact table connecting to multiple dimension tables. Now, for your snowflake schema, this was what I was explaining, where we have your dimension table further broken down into sub dimensions. So in this case, our fact table is fact internet sales here. So if you look at this particular schema, so here we have fact internet sales here. We have the customer table describing the customer describing customer, currency describing currency. This is our date, sales, this is territory and product. So now, all of this, you can see these other ones are directly related to your fact table. But the other ones that are that have been broken down from like these products, this is like the sub-dimension of products, are not directly related to facts. They are related to the dimension tables that they have been further categorized from. So this is basically what Snowflake looks like. So let's say, for example, that for customers as well, we have like other categories. Maybe, oh, there's a table that is now defining senior citizens customers, and maybe just civil servants and stuff like that. You have like 2 tables that have been that are categorizing your customer. When you bring them into your model, you are not relating them directly to your facts. You are now relating them to your customer. But your dimension, your dim customer will have to be directly linked to your facts table. But anything that is like a further categorization of this will be linked to this, the same way that these two have been linked to products. Please let me know, do you understand what Snowflake is and what star schema is? Do you need me to go over any part of this again? Okay, thank you. So I think what I'll do now is to show us the practical example in Power BI, and then we can come here and we can come back and I'll just walk us through the best practices and common mistakes that we should look out for. So now let me open my Power BI. Okay, Mercy, do you want to
Yeah, I noticed a participant gives a thumbs down. So I don't know if that person has a question, so they can call your attention before you proceed. Yeah.
All right, thank you. Okay, so I'm going to bring in, I have a sales data that I'm going to use to um, show us the practical example in Power BI environment. So here I'm bringing in my data. And yes, one of the things that you should also take note of is it is best practice to always go into Power Query first when you are importing your data into the Power BI environment. So this is because Power BI will predict data types for you. Yeah, it also detects data types, but sometimes it doesn't detect them right. So it's important that you also check to be sure that the data types are correct. And it is best practice to also relate your tables using your integer columns. That's like the customer ID, product ID, and the likes. So now I'm going to bring in these seven tables into Power BI environment. But I'm going to transform first and just quickly see if my data types are good. And then we can just put them into the desktop environment. So please, if you have any questions, you can ask while this is going on. Okay, so we have our data imported into the Power Query environment. So I'll check for, okay, I think the data types here are all good. Customer, I'm just going to focus on my primary keys basically and ignore the rest. But those are the ones that I need to create a relationship. So product key here. Mm. That's good as well. Okay. So yeah, I think we're good now. And now I can just close and apply this. So now there are 7 tables here, right? But um, 2 of these tables are sub-dimension of products. And I'm going to ignore them for a few minutes while I explain star schema and then come back to them. So our data is currently loading into the desktop environment. So we can give you some time. And another thing that you should always do is please don't ignore your model view after importing your data into the desktop environment, because it's easier to just focus on the visuals and ignore your model view. It's okay to always come back to double check things. So now I'm going to go to my model view, and like I said, Power BI will also detect relationships. I think I mentioned this while I was explaining the primary key or something, but yes, Power BI has auto detected, but it's always important for you to review so that you are sure that the keys has been used, the way the relationships are is what you want for your model. So let me reduce this. Let me minimize so that we can see what the entire. So these are the extra 2 tables that I said. So I'm going to ignore them for now. You can see that Power BI has also detected the relationship. Yeah. But it did not detect the relationship between these two to their dimension table, to the dimension table that they have been categorized for. I'll come back to that. But see, this is what a star schema basically looks like. So we have our fact table, which is fact internet sales, connecting to multiple dimension tables. So now I'm going to click on, let me use the customer, and this is where you can find everything, the properties pane. It is on the right side after your data pane. You can minimize this, you can expand this. So this is where you can find everything about your relationship. So once I click, but I have to click on that relationship for me to be able to view everything about that particular relationship. And if you look at this relationship, you can see that the star is on the sales table, which is fact internet sales, and the one is on the BIM customer table, which is the dimension table. So here you can easily see that this is your dimension table, this is your fact table. And let me go back, let me go to table view and let me show us what I think I should have showed us in Pathway, but it's fine, I can show us here as well. So what I was saying about you detecting your fact table, if you look at your fact internet sales, you most likely see your sales amount, quantities ordered, and things like that. Maybe profits made, discount that has been given, and stuff like that. So here, let me see. Okay, order quantity, see unit price, extended amounts, basically numerical data. This contains more of numerical data. This is your sales amount, this is the product cost. You can see everything here and the other dates. Now, you would also find all the primary keys of all these other tables inside your fact table. So you can see your product key here. You can see your order date key here. You can see, let me see, customer key here. You can see your currency key here. You can see your sales territory key here. What other tables do we have? Yes, I think that's just it. Your product, customer, currency, and territory. So you can see them here. So your fact table would contain the primary keys of your dimension table as a foreign key inside of it. So let me go back to my model view so that we can move on. So now let me explain the relationship that we have here. So our fact table, you can see the two tables that have been related. This one here is facts, and the column that has been used is customer key. And this is the customer, and the column that has been used here is the customer key. And here you can see the cardinality, many to one. You can use many to one and one to many interchangeably. It's basically just the one that was used to connect to the other. So let me quickly delete. So if you want to delete this relationship, you can just right click on it and click delete. I'll create a relationship back. I just want to, it's currently showing many to one here. So now if I want to recreate this relationship, customer key, I'm going to bring in customer key from customer table down to my facts table and drop it here. It's going to now identify it as one to many instead of many to one. So whenever I see this type of change, you don't have to be concerned about it being another type of relationship. One to many is the same as many to one. So you can see my cardinality here showing as one to many, and I'm connecting my customer to my facts, and you can double check your keys that they are the correct one. And yes, the cross filter direction, we have two types. We have the single and the both. The what cross filter direction means is basically the direction of your filter, and ideally your filter is going to move from your one side, sorry, to your many side. So for a single cross filter direction, you are using your dimension table, that's your one side, to filter your many side, which is like the appropriate thing to do. So now if I switch to both for my cross filter direction, it means that I'm saying that I want both of them to start filtering themselves. I want my many sides to be able to filter my one side, and my one side to also be able to filter my many side. And this can also introduce like maybe duplicate results and things like that, and you would want to avoid that. You can use your both cross filter directions if you are very sure, if you are certain, but basically the most recommended is single. Just use your single, as your one side is filtering your many sides. So this is what this is. And here I can decide to not make this relationship active. If I don't make it active, the relationship is there, but it's not functioning. But no, we want this to be active. So I'm going to check this and I'm going to click on save. So basically, this is how you can create your relationship in Power BI. If in Power BI, if it has not already been created. Remember I mentioned that Power BI auto detects, but you can review. So for this other one, we're just going to review to see. Okay, sales territory, this looks good. Single, let's check for our products. Okay, product key, using product key here. Single, active, okay. Okay, our currency as well. So this looks good. So this is basically what your star schema looks like. One fact table connecting to multiple dimension tables. So now I'm going to bring in my sub dimension tables for product. So now we have two sub dimension tables which have been related. Power BI have also detected this relationship. So let me see what this relationship let me see the keys that are connecting this relationship. I'm going to expand this properties pane again. I want to be sure. Okay, this is products category ID in the subcategory table is connecting to products category. Okay, so which means that our product subcategory has the foreign key, as the primary key of products category inside of it as a foreign key. So now we need to now decide which of these two tables has the primary has the key that we can use to relate to products. So now what I'll do is I'll go to my table view and check what we have in products. Let me click on products and see. So for products, we have products key, we have product alternate key, we have product subcategory key. These are the three keys that we have here. So this is already telling me that I have product subcategory key here, which means that I can relate this to the subcategory table. Please note that we have two subcategories of products, one categorizing into like the products category and the other subcategory. So now I want to find out, these two have already been related. Now I want to find out which of these two tables can I link to my products table to create that relationship between the three tables, and in the long run connecting to the fact table, because your product is already connecting to fact table, which means that if I want to carry out a calculation for total sales that was made based on a certain category, I can conveniently make that calculation, because now these two tables are going to be linked to products that is already linked to fact table. So let me go to my subcategory and see. Okay, so this is the key that we're using. Here it is titled products subcategory ID, and in products it is titled product subcategory key. These are the same, but you can basically just confirm to see if the numbers of the distinct records that you have here correspond to the distance that you have here. So now I'm just going to see, yeah, I think here 37. Yeah, so let me come here to subcategory and check the key, the ID as well. So yeah, I think this should also do. So now I'm going to go back to my model view, and I'm going to drag my subcategory ID in my subcategory table to subcategory key in the dim products table. So this is it here. I'm going to drop it here, and I'll confirm that my keys are correct. Okay, subcategory ID, subcategory key. My cardinality is one to many. First filter direction is single, relationship is active, and I can click save. So yeah, this is what a snowflake looks like. Now we have an extension of what our star schema looks like. We no longer have just fact table connecting to dimension tables, because we now have sub dimensions that are now attached to our dimension table. So another way that you can, so let's say that you also want to, I just want to show us this in case we might need to use it. So let's say, for example, I want to like just break down my I want to see the relationship between some other tables. I already have like my model here, my central model here. I can just bring in, so let's say that I want to see all the tables that are related to my fact in the maybe aspect of you having many other tables, or you just basically want to do like a quick check. You can click on your table from the table from the data pane, sorry, and click the three dots, and you can see add related tables. It's going to bring that table in alongside every other table that are related to it, and see what you have here. So you can also review this to be sure that the relationships are like as they should be. So basically this is what your data model view looks like in Power BI, and this is how your this is how you can relate tables together, confirm your cardinality and your cross-data directions. Please, are we good to go on the practical aspect that I just showed us? Do we have questions? Do we want to point out anything before I move to back to the slide to walk us through the do's and don'ts? Okay, so back to the slide. So best practices and common mistakes. For the do's, use a star schema. Yeah, this is always advisable. Use a star schema. But in the case where you have like the sub dimensions like I showed us, yes, you can make use of your snowflakes. Name tables and columns clearly so that you are sure you're not confused, and set correct data types up front. I already told us that is important. Power BI would auto detect here, but it's also important that you review this, go through them again to be sure that your data types are correct. Build relationship on integer keys. I mentioned this somewhere as well at some point. Use measures over calculated columns. Okay, so I don't know if I don't know if I've already done DAX, or it's something that we're going to do after this session, but there's something called measures and calculated columns, and basically, I think somebody just left a message, but I'll try to check once I'm done with this. There's something I will call measures, which is which are used for, basically summarizes your data. A calculated column creates a record of each rows based on your calculations. So now, for what you're trying to do is you're trying to make your model, to reduce the size of your model. Basically, your goal should be, oh, I don't want to have too many things in my model. So that's why it's also important to remove unnecessary columns, and that's our first thing on our don't load unnecessary columns. Even when you load them and you find that, oh, you don't need them, it's okay, you can go back to your Power Query environment and delete them. Don't create many to many relationships without understanding them. I already mentioned this, because you can introduce ambiguous filtering to your behavior, to your report. Don't use bi-directional filters unless necessary. That is like the both ways. So it's advisable to stick with the single direction for your cross filter. Don't use complex calculated columns. You can always see how you can do a workaround in Power Query. So instead of creating multiple calculated columns or complex calculated columns in your desktop environment, and don't ignore the model view. I mentioned this as well. After importing, make sure that you go back to check what is happening there. If your relationship are still intact, if nothing has gone wrong. So this brings us to the end of today's session. Let me see. Okay, I'm trying to check messages
Well,
on the
we have a
chat.
question in the chat box
Okay.
already. Do you want me
Okay,
to
thank
read them
you.
out, or you go over them yourself?
Yes, yes, please, you can. Thank you.
All right. The question is from Kehinde. She has two questions there. The first one is, where does the surrogate key come in?
Okay, in terms of, let me see. Kennedy Abdulaziz, right?
Yes.
Okay, and our second question is, in a situation where an analyst is in charge of putting customer account and one of the customer upgrade from the to premium, session, how will the organization need to see both? Okay. This is like in terms of the advanced data modeling aspects that she does ask in terms of surrogate key. And in a situation where an analyst is in charge of GoTV customer records, and one of the customer, I'm reading the second question now, and one of the customers upgrade from basic to premium subscription, how will both records be kept? Because the organization needs to see both. Okay, so I think that there's a concept for this, but in all honesty, I don't have, I don't have the response to this, but I know there's a concept for this because I've also like read about it before. And I think there was like a session I attended where this was explained, where this was basically expanded on. So Kennedy Abdulaziz, is it okay if the response to this question is dropped on the group chat later on in the community?
ID
I
Analytics
think
wants
there
to
are more.
come in.
Okay, all right. Please go ahead.
Thanks so much, Olabisi. Pardon me, you can hear me, right? I'm in a noisy environment, actually.
Yes,
Can you
I
Yes,
hear
we
can
me?
hear you.
can.
Please go ahead.
Okay.
Yes, you can go ahead, please.
All right. Thanks so much for the session today. So let me just attempt to answer this question briefly. First is when they
Okay.
say surrogate key. What does that mean? What does surrogacy mean? So surrogate means substitute. So it's not the basic thing, it's not the fundamental thing. So when we talk of different keys, when it comes to data modeling, there are quite a number of them. So you've taught us, Olabisi taught us that we have primary key, we have foreign key. One of them is also the surrogate key. But just
Okay.
so that we understand where the surrogate key would come in, let me quickly relate it to the second question. So what you're asking, kind of, from your second question is about the concept of slowly changing dimensions. And what that means is that there are different kinds. So you have SCD 0, 1, 2, 3, up to 6 actually. But in reality, a lot of the times SCD zeros to 3 is what people model for. But the basic line to this is that you want to determine how you manage changes in your data set. And the changes we're talking about has to do with the dimension itself. So for your case now, you have someone, there's a customer already who is on the basic subscription. That customer, let's say the customer is Kende, the customer has been logged into dimension table for customers. And now after a while, the customer is changing their subscription from basic to premium. Now, as an analyst, you need to make a decision. How do you want to manage this particular change? And that's where the concept of SCD comes in, slowly changing dimension. So if you say that you want to ignore the changes, so which means that we are going to keep the initial record only. Whatever changes that came after would not be affected on the dimension table. That is SCD0. When we say that we want to overwrite what currently exists in the data, so want to change their plan, want to overwrite their plan.
Yes. Yeah,
You
no,
can't hear me.
yeah,
Okay.
you were a little bit off for some
Okay.
time.
Yeah. So, but we got the SCD0. SCD0 is we are ignoring whatever changes happen to our dimension. So a customer move from basic to premium. SCD0 says that we retain the basic. We ignore that the customer is now on premium. So the data stay as is. But when we say that we want to now overwrite the data, now that the customer is on premium, we go to their subscription status of the column in our dimension and we change it from basic to premium, overwriting it. That is SCD1. But for your case where you're saying that we want to keep both, so what that means is we're going to do SCD2, which implies that we would keep the original record and we now have a new record entered for that customer on that same table. But think about it this way. The primary key for the customer Kende is KO1. So if we are entering customer Kende onto that table again a second time, that becomes a a primary key on the dimension table because now we already have duplicate if we still want to use KO1 as the primary key to connect to whatever fast table that's supposed to connect to. And that is the only reason why you need to now bring in the surrogate key. So surrogate key now means that you are bringing in a substitute key that would act in place of your primary key because your primary key can no longer function the way it's supposed to function. They are now duplicates. And your surrogate key would just be like you have an integer. So the first record for that customer will be 1. The second record, new record now will be 2. And you continue that way. And that new key would also be affected on your fact table such that all of the transactions that had happened for when the customer was on basic, all that will be entered as key 1, that's for customer 1 on the fact table, and every new record that would come after now for when the subscription is premium, that will be entered as 2 on the fact table. So that's simply more what's the surrogate key and how it ties to SCD what it implies. I don't know if this answers your question a bit, Candy. Did did we hear me?
Yes,
Very clearly,
thank
yes.
you for
I
your
do.
All right.
response.
But Kehinde can't
Yeah,
respond. She said her background is noisy.
Okay, but she got the
so yeah, I think
response,
you may
right?
have it first.
Give a reaction, Kehinde, if you can hear us. She
Oh,
did.
super.
Okay,
All right.
thank you so
Thanks
much
again,
for the
Olabisi. Thank you so much.
idea. Thank you, everyone. It
Thank you
was
so
nice
much.
joining the call.
Thank you so much, Olabisi. It was
Thank
an
you.
enlightening session. Thank you for coming on the call. If you have questions, you have the floor now. If you have questions for Olabisi, kindly go ahead. Tokpa gave a thumbs down at some point. If you are still not clear on anything, you can ask Olabisi your question. Or if you would want Mr. Musin to do that, he's still on the call. Anyone, any question? All right. For anyone who is on the call and is not a member of our WhatsApp community, I just dropped the link in the chat. Kindly use the link to join the WhatsApp community and also follow our LinkedIn page. We have resources for you to brush up your skill if you're a learner or a beginner, and if you're an expert as well. You can always share the link with your network as well. It's not just for you. Good things are not meant for just one person. So we'll be hosting this again come the last Saturday in the month of May. So kindly stay tuned. Let's give Olabisi a reaction. She has done justice to data modeling today. So the last Saturday in the month of May will be 30th of May. Please mark your calendar. We'll be here again. Someone else will be coming to continue the Power BI series. And until then, keep reading, keep learning, and then don't forget to follow our check out our, well, what's it called, our YouTube page as well. We have resources on our YouTube page, our LinkedIn page, and our WhatsApp community. We have experts in the house to answer your question. Don't forget to share with your network. Thank you everyone for joining us today. See you not next month. We are in May already. See you on the 30th. Thank you.